Good morning everyone. I'm Reshma Priya from CSE AML Department C section. Today our course title is AI Foundation. Today I have taken the topic Cognitive Robotics and Foundation. Course outcomes for the Cognitive Robotic and Foundation. There are three course outcomes for the topic. First one is understand the fundamental concepts, principles and architecture and cognitive robotics and how they integrate artificial intelligence with robotic system. Coming to the second course outcome, it analyzes how cognitive robotics perform perception, learning, reasoning and decision making using sensors, machine learning and intelligent algorithms. Coming to the course outcome 3 is it explains the application of cognitive robotics in real world domains of healthcare, manufacturing, autonomous vehicles, etc. Now coming to the introduction, robotics is a branch of engineering and science. It focuses on designing, building and programming robotics. Traditional robots perform pre-programmed tasks. Modern robots aim to become more intelligent and autonomous. Modern robots aim to become more intelligent autonomous. Traditional robots perform pre-programmed tasks. Explain. Robots are moving for simple missions to systems capable of thinking and learning. What is cognitive robotics? Cognitive robotics combines many types of AI, artificial intelligence, robotics, cognitive science. There are three types of cognitive robotics that combine artificial intelligence, robotics, cognitive science, etc. It studies how robots can perceive, learn, and reason. It inspired by human thinking and behavior. Explanation for cognitive robotics. Cognitive robotics attempt to mimic how humans understand and interaction with world. Why cognitive robotics? Traditional robotics cannot adapt to new situations. Real world environments are unpredictable. Cognitive robotics help missions to understand surroundings, making decisions, learn from experience. For example, a robot that learns to pick objects of different shape. Cognitive robotics helps missions for understanding surroundings. It makes decisions, learn from experience. Example for cognitive robotics is a robot that learns to pick objects from different shape to that shape. Goals of cognitive robotics. Many objectives include creating intelligent robots, enabling robots to learn autonomously. It improves human robot interaction, developing robots that can solve complex problems. History of cognitive robotics. At 1950s, early robotics and research was created. After that, again in 1980, they introduced machine learning. After that, in 1990, cognitive robotics concept engaged. Today, integration of AI, deep learning, and robotics. Explain how the technology development made cognitive robotics possible. There are three generations that cognitive robotics history created. At 1950s, the firstly early robotics and AI research was created. After that, again in 1980, they introduced machine learning. After that, 1990s, cognitive robotics concept emerged. Today, the integration of AI, deep learning, and robotics explain how technology development made cognitive robotics possible. Traditional robotics versus cognitive robotics. Traditional robotics, it fixed programming, limited adaptability, performs repetitive tasks. Cognitive robotics, learning ability, adaptive behavior, intelligent decision making. Now we are discussing about differences between traditional robotics versus cognitive robotics. In traditional robotics, the programming is fixed. It has limited adaptability. It also performs repetition tasks. In cognitive robotics, we have learning ability. It is adaptive behavior. It is intelligent decision making. Core components of cognitive robotics. There are many key components include cognitive robotics, perception, learning, memory, reasoning, decision making, action. These components work together to create robots. Perception in cognitive robots. Perception allows robots to understand their environment using sensors. Common sensors include cameras, microphones, touch sensors, lizard sensors. Example, a robot detecting obstacles using cameras. Learning in robotics. Robots improve performance through experience, types of learning, supervision learning, unsupervised learning, reinforcement learning. Example, a robot learning how to walk by trial and error. Robots improve performance through experience, types of learning, supervision learning, unsupervised learning, reinforcement learning. Example, robots learning how to walk by trial and error method. Reasoning ability for robotics. Reasoning allows robots to analyze information, solve problems, make logical decisions. Example, a robot deciding the shortest path to reach a destination. Reasoning ability example for robotics. A robot deciding the shortest path to reach destination. Reasoning allows robots to analyze information, solve problems, and make logical decisions. Memory systems for robotics. The memory system helps memory robots store information. There are types of memory systems: short term memory, long term memory. In short term memory, the data is temporary. In long term memory, the data is stored and knowledge. Example, remembering object locations. Decision making in robotics. Cognitive robotics must decide what action to take next. Decision process. There are three steps for decision process. First one, observe environment. Second one, analyze information. Third one, choose best action. It is used in autonomous navigation systems. There are some decision making for the robotics. Cognitive robotics must decide what action to take next. Decision process, observe environment, analyze information, choose best action, used in autonomous navigation systems. Cognitive architectures. Coming to the cognitive architectures are frameworks that organize robot intelligence. Example, there are many examples for cognitive architectures. SOAR, ACTAR, they also integrate perception, reasoning, learning. Artificial intelligence in robotics. Artificial intelligence provides intelligence to robotics. Artificial intelligence techniques used include machine learning, neural networking, deep learning, knowledge representation. Artificial intelligence means it is a man-made thinking power to capacity. Machine learning in cognitive robotics. Machine learning helps robots learn from data. There are many types included in machine learning like supervised learning, unsupervised learning, reinforced learning. It is also used in object recognition, navigation, task learning, etc. There are many types of learning that is came from machine learning. Supervised learning, reinforcement learning. It is also used in object organization and navigation task learning. The computer vision of robotics. Computer vision allows robots to interpret visual information. Applications include object detection, face recognition, scene understanding, used in self-driving cars and security robotics. The natural language processing. Natural language processing allows robots to understand human speech. Example, voice assistants, customer service robots, smart home robots. This improves human robot communication. Autonomous robots. Autonomous robots operate without human control. There are many features for autonomous robots: self-navigation, environment understanding, decision making. Example for autonomous robots: delivery robots, drones, self-driving vehicles. Applications of cognitive robotics. Major application areas are healthcare, manufacturing, education, transportation, service, industry. These systems improve efficiency and automation. Healthcare applications. Examples include surgical robots, patient monitoring robots, rehabilitation robots, elderly care assistants. These robots help doctor and improve patient care. Industrial applications. In factories, cognitive robots help with smart manufacturing, quality inspection, automated assembly, collaborative robots. They increase productivity and accuracy. Challenges in cognitive robotics. Major challenges include complex real world environments, safety concerns, ethical issues, high development cost, limited general intelligence. Future of cognitive robotics. Future developments may include more human like robots, advanced AI learning, improved emotional interaction, robots assisting in daily life. Explain that cognitive robotics will transform many industries. Conclusion. Cognitive robotics combine AI and robotics. It enables robots to perceive, learn, and reason. It has application in healthcare, industry, and services. It will play a major role in the future of intelligent missions. It end with thank you.